So hello guys, in this video we are going to solve this problem. So in this problem it is given that for any positive integer n, let Sn be a function which is defined from 0 to infinity to r, and this function is the summation of this thing which is cot inverse of 1 plus k multiplied by k plus 1 x square divided by x, and summation goes from k is equal to 1 to n. And where for any x belongs to real number, this cot inverse x is lie between 0 to pi, and this tan inverse x is lie between minus pi by 2 to pi by 2. Then you have to tell which of the following options are true. So there are four options and you have to tell which options are correct. So let's see how we can do this. So what we can do, first of all, we have given this thing. So let's simplify this. We have this summation in which the numerator of this thing is 1 plus k multiplied by k plus 1 x square, and the denominator is x. So what you can do, you can write this x as k plus 1 times x minus kx, and now this is the formula of same as cot inverse of kx minus cot inverse of k plus 1 times x. This and this thing are same. So uh, here we have k times k plus 1 times x square. So there are two pairs, one is this kx and one is this k plus 1 times x, and in the denominator we also have this and this. So this is same as cot inverse of kx minus cot inverse of k plus 1 times x. Now we have uh, this summation in the form of difference of two terms. So now we put different values of k. So let's start by k is equal to 1. So we have cot inverse of x minus cot inverse of 2x. And if you put k is equal to 2, you have cot inverse of 2x minus cot inverse of 3x. If you put 3, then you have cot inverse of 3x minus cot inverse of 4x. And so on. The Tn is cot inverse of nx minus cot inverse of n plus 1 times x. Now if you add all of these, so this will cancel, all terms will cancel, and the remaining thing is only this first term and this last term, which is cot inverse of x minus cot inverse of n plus 1 times x. So this is our summation. Now this thing you can further write in this way, like the cot inverse of 1 plus x times n plus 1 times x divided by n plus 1 times x minus x. So in this way you can also write this thing, this whole thing. So I write just that here. Now this will come in this form, like n plus 1 times x square plus 1 divided by nx. So in the problem we have to find out the value of S10. So we have to put n value as 10. So if you put n value as 10, this will come like cot inverse of 11x square plus 1 divided by 10x. So and we know cot inverse of 11x square plus 1 divided by 10x. So we know cot inverse of something is same as pi by 2 minus 10 inverse of that thing. So we can say that this option is correct. So for all x greater than 0, we can say that this summation up to 10 terms is same as this thing, pi by 2 minus tan inverse of 1 plus 11x square divided by 10x. So now let's move to the second option. So in the second option, it is given that this part of this Snx, where the limit goes n tending to infinity, and we have to tell this is equal to x or not for all x greater than 0. So this is the thing. So let's see this. So in we have this limit, and we also know the snx we just calculated previously, it is equal to this thing. So we just put that here, and we have cot of cot inverse of this thing. So we can write this thing same as simply this inside thing, which is this thing. And if you put n tending to infinity, then we have this n plus 1 times x square divided by nx. So this n plus 1 times x square plus 1 for n tending to infinity, we can write this same as like n plus 1 times x square. We can ignore 1. And if you see, then n tending to infinity, this and this will also cancel, and 1x will also cancel, and the remaining thing is only this x. So we can say that this option is also correct. For all x greater than 0, this limit is equal to x. So now let's move to the third option. So in the third option, it is given that the equation s3x is equal to pi by 4 has a root in 0 to infinity. We have to tell. So let's see how we can do this. So we have the general formula for s and x, and it is this. So if you put n is equal to 3, then we will get s3x as this 4x square plus 1 divided by 3x. So now in the problem, it is given that this is equal to pi by 4, and we have to tell there is some root lie between 0 to infinity for this equation. So we put this as 3x is equal to pi by 4, and we can say that this 4x square plus 1 divided by 3x is equal to like 1. Then we have cot inverse of 1 is equal to pi by 4. Then it is possible. Then here we have this quadratic equation after simplification, and here if you see the determinant, it is b square minus 4ac, which is less than 0. So this is uh, uh, the condition for the imaginary roots. So we have no real root. So in this case, we have no real root. So this option is incorrect. So this option is incorrect. This does not have a root in 0 to infinity, because the d of our quadratic equation is less than 0, and it has imaginary roots. So this s3x is equal to pi by 4 has no root between 0 to infinity. And the last option, we have this tan of s and x is less than equal to half for all n greater than equal to 1 and x greater than 0. This we have to check. So tan of s and x we have cot inverse of this thing. So we have tan of cot inverse of this thing, and for all x greater than 0, we know that like the tan of cot inverse of x, it is same as 1 by x. So we can write this. So we have this property. So now we have here x greater than 0, and this inside argument is also greater than 0. So we can directly apply this property, and we can write tan of cot inverse of this thing as 1 by x. So which is in this case, it will become like this thing, which is nx divided by 1 plus n plus 1 times x square. And in the problem, it is given that we have to check this is always less than equal to half or not. So if you put like limit n tending to infinity in this case, so it will become like nx divided by n plus 1 x square, which will further simplify to 1 by x. And now x is greater than 0, there is no restriction. X can be as small as like 0.000 something, in which case this quantity is very big. So this is not restricted to this half bound. So in this case, we can say that this option is not correct. So only A and B option are correct in this case. So in this way we can solve.